Okay, this is the Integrated 3 Module 10 review for the test that is coming up. So Module 10 review for Integrated 3. Here we go. Let's get started on number 3. Just so you know, like I said in class, I am not going to do every single problem on this review. I am going to basically skip around, do some of each type. There's a lot of different types of problems. Do some of each type based on the suggestions that you guys gave me. Okay. My advice to you guys is to try every problem on your own and then check to see how I do it. So for example, I'm going to start with number 3. You should try it on your own first. See what you get. If you get stuck, then come watch my steps. Okay, but try it on your own. See if you can figure it out. That's the best way that you're going to be able to learn how to do it. Okay, let's get started. So number 1 through 7 are all asking you the same thing. Find the inverse of the function. Okay, so y equals 3 over 4 x cubed minus 1/2. The first thing I'm going to do is, the goal is to isolate the x, right? So I'm going to add 1/2 to both sides. Add 1/2. Add 1/2. That cancels there, so it's y plus 1/2 equals 3/4 x cubed. There you go. Next, what I'm going to do is multiply by the reciprocal of 3/4 to get rid of it, right? I want to get rid of 3/4. So the reciprocal of it is 4 over 3. I'm going to multiply both sides by 4 over 3 because that will cancel it out. So here, just distribute it, and you're going to get 4 over 3y, like that. 4 over 3 times 1 over 2. 4 times 1 is 4. 3 times 2 is 6. So 4/6 equals, what you're going to do on this side is you're also going to multiply by 4 over 3. So you're going to multiply that times 4 over 3. What happens there is that the 4 and the 3 cancel out. That cancels, that cancels. So it's just x cubed. So 4 over 3y plus 4 over 6. 4 over 6 is 2/3. So 4 over 3y plus 2/3 equals x cubed. And now what you're going to do is get rid of the x cubed, the cube, by taking the cube root of both sides. Take the cube root of that, take the cube root of that. That cancels, so continue over here. It's going to be x equals the cube root, I forgot the little 3 there, the index, the cube root of 4/3 y plus 2/3. Last step is to change the x with the y and also change it to f inverse. So this is your final answer. F inverse is the cube root of 4 over 3 x plus 2/3. And that's your final answer. Now I believe it says confirm your result. Yes, it does right there. That means check using composition. So we're going to do a composition to check that our answer is correct. So I'm going to go ahead and plug in this into this. Okay, the inverse into the original. So it's going to look like this. Y equals 3 over 4 x cubed minus 1/2. So what I did is I wrote this one, 3 over 4 x cubed minus 1/2. I took out the x, left empty parentheses. I'm going to plug all of that in there. So the cube root of 4 over 3x plus 2/3. What's going to happen is stuff is going to start canceling out. The first thing that cancels is the cube with the cube root, leaving you with just y equals 3 over 4. That's that same 3 over 4 that we have right here, this one. And then the radical is gone and the cube is gone. So all you have in there is 4 over 3x plus 2/3. And then minus 1/2. To simplify it, I'm going to go ahead and distribute like that. So y equals 3 over 4 times 4 over 3. That's 12 over 12. That's just x, right? Think about it. 3 times 4, 4 times 3, 12 over 12. They basically cancel out. That's just x. For the next one, 3 times 2 is 6, 4 times 3 is 12. So 6 over 12. You can simplify that in your head. 6 over 12 is 1/2. Plus 1/2. And then minus 1/2 that comes from the outside over there. So then the negative 1/2 and the positive 1/2 cancel, and you have y equals x, and that is your final answer. And that confirms that it is the inverse. For 6, we're going to follow the same steps. First, I'm going to change g of x to y. Y equals 3 times x minus 9 squared plus 4. We're going to isolate the x. The first thing that needs to go in this problem is the 4. We're going to subtract 4 first. Minus 4, minus 4. That's y minus 4 equals 3 times x minus 9 squared. The next thing to go is the 3. Do not take the square root to get rid of the square. First, get rid of that 3. So we're going to divide by 3. Divide by 3. So y minus 4 over 3 equals x minus 9 squared, because the 3 and the 3 canceled. Now that you have that, you might try to add 9 to cancel the 9, but you can't do that because it's trapped inside the parentheses. You got to get rid of the square now. So we're going to take the square root of both sides. Square root, square root. So what I'm going to have left is square root of y minus 4 over 3 equals x minus 9. Just x minus 9 because the square and the square root canceled out. And finally, remember the goal is to isolate the x. I'm going to add 9 to both sides to get rid of it. So we're going to add 9. I'm going to keep going over here. We add 9 to both sides. Add 9, add 9. So what you get is x equals, I moved it to the left side also, the square root of y minus 4 over 3 plus 9. The 9 is outside of the radical. And there you go. That is the, change the x to y and the y to x, and also write it as an inverse. So g inverse, right? It's g of x, so it's g inverse. G inverse is the square root of x minus 4 over 3 plus 9. Make sure the 9 is outside of the radical. So plus 9 like that. There you go. Check using composition. What I'm going to do in this case is I'm going to plug in the original into the inverse. Okay, so the original into the inverse, see what we get. So I'm going to take the inverse. And in it I'm going to plug in the original. So it looks like this. Minus 4, something minus 4 over 3 plus 9. 9 over there at the end. Okay, plug in the original in there, which is all of this right here. So 3, is it going to fit? I don't think I left enough space for it, so let me fix this. Bigger parentheses, then minus 4, and then plus 9 outside, like that. Alright, so now let's plug it in. It's going to be a 3, parentheses, x minus 9 squared plus 4. Okay, there we go. Now let's simplify that. We're going to have the square root of, the first thing to cancel here is the 4 and the negative 4. This 4 is inside parentheses, but it's inside these parentheses that are really not necessary at this point. So the 4 and the 4 are going to cancel out. That leaves you with 3 times x minus 9 squared over 3, and then plus 9 is outside. Like that. Next thing to cancel is the 3's. So it's square root of x minus 9 squared, and then plus 9 outside. Now the square and the square root cancel. You couldn't cancel it before because it had a 3 there that was not a perfect square. It had this 4 in the way. Now that's all that's left, so that you can cancel the square and the square root, leaving you with just x minus 9 plus 9. X minus 9 plus 9. Now they cancel, and that's just x, and that's what we wanted. That confirms our work. Okay, number 7, same thing, same steps. I am going to change it to y. So I'm going to use all the space. I'm going to write it over here. The square root of 1 over 4 x minus 5, and then the minus 4 is outside of the radical, right? Minus 4, like that. First thing I'm going to do is kick out the 4. That needs to go first. Plus 4, plus 4. So it's y plus 4 equals 1 over 4 times x minus 5, the square root of that. Okay, now what you need to do is get rid of the square root. To get rid of the square root, what you're going to do is you're going to square both sides. So we're going to basically put this in parentheses and square it. Put this in parentheses and square it. So on the left side, what you have is y plus 4 squared. Don't multiply it out, just leave it like that. That's fine. On the right side, the square and the square root cancel, leaving you with just 1/4 x minus 5. The next thing to do is to get rid of the 1/4. Since it's 1/4, I can just multiply times 4 over 1, the reciprocal, to cancel it out. So I'm going to multiply both sides times 4 over 1. Like that. Which is just 4, right? I could just erase that and write 4. Just 4. I'm going to do the same thing here, times 4. And that's going to cancel. So that leaves you with just x minus 5 on the right. On the left is 4 times y plus 4 squared. And finally, we're going to get rid of the 5 by adding it. I'm going to continue over here. So it's going to be x equals 4 times y plus 4 squared plus 5. Change the x with the y and also write it as f inverse. H inverse in this case because it's h of x. So it's going to be h inverse equals 4 times x plus 4 squared plus 5. There you go. That is your inverse. Let's confirm it by plugging it in. I'm going to plug in the original into the inverse. So that's what I'm going to do. Let's see. Use this space right here. The original into the inverse. Here we go. It's going to be h inverse of h, right? That means the original into the inverse equals 4 times parentheses, a lot of stuff, plus 5. Now there's a plus 4 here, but this empty space that I left here is for the original, for all of this. Square root of 1/4 x minus 5 minus 4. So all of that is going in there. Here we go. Let's hope it fits. I don't know if I left enough space. 1/4 x minus 5 minus 4. There you go. And now you simplify that. The first thing to go is the 4 and the negative 4. Those cancel. So what you have left is 4 times the square root of 1/4 x minus 5. Close the parentheses and square. Right? That's that one right there. And then plus 5. Now what happens is the square and the square root cancel out, leaving you with just 4 times 1/4 times x minus 5 plus 5. 4 times 1/4 cancels. These two cancel. So it's just x minus 5 plus 5. The 5 and the negative 5 cancels. It's just x. Done. Okay, number 8. Restrict the domain of the function and find its inverse. Verify your result by graphing both the function and its inverse on the same graph. So restricting the domain means that we want our domain in order to work. Okay, we want our original function to be 1-to-1 so that when we do the inverse, it's also 1-to-1. This is not a 1-to-1 function right here. Okay, this is a parabola. It's a parabola that opens down. So it's a parabola that looks like this. Oops. It's a parabola that looks like this. So it's not a 1-to-1 function. It's actually a many-to-1 function, meaning various inputs give you the same output. For example, a -2 could give you -5, and then a +2 could also give you -5. Just an example, right? So you could have multiple outputs for the same input. That's many to 1. We don't want that, because if we do the inverse, it's going to be 1 to many, and that's not a function. So we restrict the domain. That's basically what it means by restrict the domain. What you guys only thing that you have to remember is that when you restrict the domain, you're basically looking for h. What is the h value of your original function? And that's how you restrict the domain. So the h value of this function, if you look at it carefully, is 0, right? This is k. This is a. H would be there in parentheses. There's nothing in there, so h is 0. So my domain depends on that. It's all values of x such that x, we're going to compare it to 0. The question is, do we want the numbers that are greater than 0, or do we want the numbers that are smaller than 0? And your answer should be greater than 0. Most of the time, we can actually choose to restrict the domain to the numbers that are less than 0, but most of the time we choose the right side of the problem. Alright, that's the domain that is restricted. Now we can find the inverse. Here we go. We're going to change that to y. -3x squared minus 4. I'm going to add 4. Y plus 4 equals -3x squared. I'm going to divide by -3. So x squared, I'm going to write on the left side, equals y plus 4 over -3. And finally, take the square root of both sides. Y square root, because that cancels the square. Keep going over here. So x equals the square root of y plus 4 over -3. Y, f inverse, equals, I'm going to write it in the correct form. Remember, change the y to x, so x plus 4 over -3. There you go. That is your inverse. It says graph both the function and its inverse on the same graph. That's what I'm going to do real quick. Graph them both on the same graph. So I'm going to graph this one first, and then what I'm going to do is just reverse the points to graph the other one. So here we go. Here's my, for this one right here, my table is going to look like this. X and Y. I'm going to use transformations to graph it. Okay, so since this is a square, a quadratic function, I'm going to use this table. 0, 1, 2, 4, 1, 0, 1, 4. I'm going to transform it. I'm graphing this one, okay? So don't worry about the inverse yet. We're just graphing this one. For this one, we said h is 0, but a is -3 and k is -4, correct? So b is not there, it's 1. H is 0. A is -3, k is -4. We're going to use those to transform the parent function table. This is the table for any quadratic function, right? So that means multiply times 1 and add 0. That doesn't do anything. So really we're not doing anything to the x values. To the y values, times -3 minus 4. So times -3 minus 4. 4 times -3 is -12, minus 4 is -16. All I did was this. 4 times -3 is -12, minus 4, -16. 1 times -3 is -3, minus 4 is -7. 0 times -3 is 0, minus 4 is -4. 1 times -3 is -3, minus 4 is -7. And 4 times -3 is -12, minus 4 is -16. That makes sense. They should be repeated. For the x values, they didn't change at all because we didn't do anything to them. There is no b, no h. 1 and 2. So those are the values for the original. Now we can graph it. Looks like I have a bunch of negatives. So -2, -16. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is obviously not going to be a perfect graph, right? Just going to be estimating a lot. -1, -7, 5, 6, 7, right about here. 0, negative 4, right about here. 1, negative 7, right about here. And 2, negative 16, way down here. So there's my graph. Oh, this is wrong. But we can easily fix it. We had already restricted the domain before, right? We said that the domain is all numbers that are greater than or equal to 0. Greater than or equal to 0. So when I did my table, I should not have used these right here. We only wanted the ones that are greater than or equal to 0. So only these three. That's the only thing we want. Because if we do the inverse of the full parabola, remember, it's not going to be a function. Okay, now to graph the inverse, all you got to do is reverse the points. It's basically these, but reversed. The inverse is going to look like this. Ignoring these two, negative 4, 0, and negative 7, 1, and negative 16, 2. So negative 4, 0, 1, 2, 3, 4, right there. Negative 7, 1, 1, 2, 3, 4, 5, 6, 7, negative 7, 1, so right about there, right, go up 1. It's a little closer to the x-axis because when I was doing these, they're a little bit, it's a little bit of a smaller difference between them. And negative 16, 2. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 2. Right about there. And so my graph looks like this. There you go. So the original is going down to the right. The inverse is going up to the left. Okay, it is a parabola that got flipped around. So it used to look like this, and now it looks like this, but we only kept the right side, so we basically only kept the top side. Okay, number 9, same idea. We're going to do the same thing. We're going to restrict the domain. This is a square root function. I should not have put a 2 there. There should not be a 2 there because for square root, we don't have to write the index there, right? So 2 square root of x minus 2 plus 1. The domain depends on h. So you know what? Since we're going to graph it anyway, let's find b, h, a, and k. b is 1, right? It would be in here. There's nothing in there. H is 2, A is 2, K is 1. So those are your values. The domain depends on H. So your domain is based on H. All values of X such that X is something greater than or less than 2. Or equal to. It could also be equal to. Greater than or less than or equal to 2. So we have to choose the correct value. To choose, you can plug in to see what makes sense. Do numbers bigger than 2 make sense, or do numbers smaller than 2 make sense? You could try different numbers. For example, let's try a number bigger than 2, like 3. 3 minus 2 is 1. Could I find the square root of 1? Yes. But a number less than 2, like 1, 1 minus 2 is negative 1. That you cannot find the square root of a negative, so that wouldn't make sense. Okay, so you want the numbers that are greater than or equal to 2. Another way to check is to look at b. If b is positive, it's always going to be greater than. If b is negative for these types of functions, it's always going to be less than, because that means that the graph reflected over towards the left. So there's your domain. Now let's find the inverse. Here we go. I'm going to write it as y equals 2 times the square root of x minus 2 plus 1. First thing I'm going to do is kick out the 1, so minus 1. So it's y minus 1 equals 2 times the square root of x minus 2. Next, I'm going to divide by 2 to get rid of this one. So I have the square root of x minus 2 equals y minus 1 over 2. And finally, remember to get rid of the square root, use square. Square both sides. So I continue over here. I have y minus 1 squared over 2 squared, right? That's what squaring the fraction means. Square the top, square the bottom. 2 squared. Not to the fourth. 2 squared. Equals x minus 2. Because the square and the square root canceled each other out. it's y minus 1 squared over 4, because 2 squared is 4, equals x minus 2, minus 2. I'm going to add 2 to both sides. So y minus 1 squared over 4 plus 2, that's the 2 that I just added, equals x. There you go, that's your inverse. All you got to do is now is change the x with the y and write it as f inverse. G inverse, right? This one's g. So g inverse is equal to, in parentheses, x minus 1 squared over 4 plus 2. There you go. And now to graph it, I'm not going to do the graph. I think you guys can handle it now. What you're going to do is you're going to graph this one using these, BHAK, using your original table. Remember the table for a square root function starts like this. So I'll give you guys that beginning. Square root function, 0, 1, 4, 0, 1, 2. Right? Using that table, those are what we call the reference points, that table, and these parameters, graph that one, and then all you got to do is reverse the inputs and the outputs for that graph, and you're done. Okay, for the next few problems, the instructions are calculate the reference points. When you guys see reference points, that just means the original table, the parent function table. Okay, so what is the original table for each transformation? So take those and then transform them using BHA and K, using your parameters. Then graph and label all the reference points. So graph and label all of them. Then state the domain and the range. For some of these, we're going to skip the range because we're going to get a shape that looks something like that, and we won't know exactly where the maximum or the minimum will be. And also describe the end behavior. Okay, so let's get started with number 13. Here we go. Okay, so I'm going to start with my parent function table for this one, and also by finding BHA and K. So first I want to know what type of function this is. This is a square root function, so I should have my numbers memorized. 0, 1, 4 for x, 0, 1, 2 for y. And we're going to transform that using our parameters, which we're going to find right now. So our parameters are going to be b, which is negative 3/2. You guys see that? This is b, it's inside the radical. But it's not 2/3, it's the reciprocal of it. It's still negative, but it's 3/2. H, which is 1. You see that inside the parentheses with the x. A, which is not there, so it's also 1. We're really not going to need it though. And K, which is 2. Using those parameters, we're going to transform this. So here we go. Remember the steps. B and H are for the x values. A and K are for the y values. So for the x values, you're going to multiply times negative 3/2. So 0 times negative 3/2 is 0. And then add 1. So it's just 1. Right, here's what I did. 0 times negative 3/2, 0. Plus 1, 1. Let's do the same thing for the last two. 1 times negative 3/2 is negative 3/2. Negative 1.5 if you want to think of it that way. Negative 1.5. It's the same thing. So 1 times negative 3/2 is negative 3/2. Plus 1, so negative 1.5 plus 1 is negative 0.5. Negative 1/2. That's what you get. Next is 4. 4 times negative 3/2. 4 times 3 is 12. 12 divided by 2 is 6. So it's negative 6. Negative 6 plus 1 is negative 5. You can check that on, do the work on the paper or do it on a calculator, but that's what you should be getting. For the y values, all you're doing is adding 2. So 0 plus 2, 1 plus 2, 2 plus 2. So 2, 3, 4. There you go. Those are your points. You're going to take those points, you're going to graph them, and that's going to be your graph. Okay. The other steps were to, let's see, what else did we have to do? We calculated the reference points, we graph and label them. Okay, so you guys can do that. State the domain and the range using the given notation. Describe the end behaviors. Okay. For square root functions, you have to give the domain and the range. Domain depends on h, range depends on y. So here's what I mean. The domain for this one, you look at h, which is 1, and you're basically saying x such that, all values of x such that x is something related to h. When you guys graph it, you will see, right, if you graph these points, that the graph goes in that direction like that, right? Instead of pointing towards the right like it should be, which is the parent function, it points towards the left. So if we're using that, you can say that it's less than or equal to 1. It's going to the left. Another way you can tell is by looking at b. If b is negative, it's going to go to the left. If b is positive, it's going to go to the right. So that's going to be x is less than or equal to 1. Where did the 1 come from? From h. For the range, range depends on k. K in this case is 2. And it's the same idea. Is the graph pointing up or pointing down? But you're not, you know, for domain you were looking for right or left. For range, you're looking for up or down. This one's going up, so it's going to be greater than or equal to 2. Another way to tell is by a. If a is positive, it's up, greater than. If a is negative, it's down, less than. There you go. That's your domain and your range. What else do we have to do? The end behavior. Okay, so the end behavior for this one, again, here's the graph. It looks something like that. That's not, of course, the exact graph, but it's going to look like that. I know that because the b is negative, so it reflected. The end behavior, all you got to say is on the left side, because that's the only way it's where place is moving towards. On the left side, the graph is going up. You guys can see on the left, it's going up. There is no end behavior for the right side because it has an initial point, so it stops. So you're going to say on the left side, as x approaches negative infinity. That's how we say left. On the left side, f of x approaches positive infinity. It's going up. On the left side, it's going up. Done. So we got the points, the graph, the domain, the range, the end behavior. 14, same idea, except it's a cube root function. So we're going to use a different initial table. For this one, our initial table is going to look like this. X, y, cube root functions. That means you're going to start with negative 8, negative 2, negative 1. Whoops, I just messed up. Negative 8, negative 1, 0, 1, 8. And then the y values are going to be negative 2, negative 1, 0, 1, 2. And we're going to transform those using our b, h, a, and k from here. Let's find those now. B is 4. You guys should be able to see that clearly now. Here's b, but it's not 1/4, it's the reciprocal 4. H is negative 2. A is not there, so it's 1. So we're really not going to need it. And k is negative 3. There you go. Using those, we can make our transformation. For the x values, remember, split these up. B and h are for the x values. Multiply times 4, then subtract 2. We can do that in our head. Negative 8 times 4, negative 32. Minus 2, negative 34. That one's definitely not going to fit in our graph. Negative 1, that's the next one. Negative 1 times 4 is negative 4. Minus 2 is negative 6. 0 times 4 is 0. Minus 2 is negative 2. 1 times 4 is 4. Minus 2 is 2. And the last one, 8 times 4 is 32. Minus 2 is 30. That one is also not going to fit in a graph. For the y values, you're going to multiply times 1, which we can skip, and then subtract 3. So just subtract 3. Negative 2 minus 3 is negative 5. Negative 1 minus 3 is negative 4. 0 minus 3 is negative 3. 1 minus 3 is negative 2. 2 minus 3 is negative 1. There you go. So you're going to plot those points. Basically, you're only going to plot those 3 because the other ones are not going to fit in your graph. You're not going to stretch it that far. Okay? So plot those points. The next thing is to find the domain and the range. These are the easiest ones to find domain and range. Cube root functions and cubic functions, the domain and the range is always the same thing. All real numbers. Cubic functions and cube root functions do not have restrictions on the domain or the range, because you can plug in anything you want in here, positives and negatives. The reason why square root functions have restrictions, like the one we just did here, is because you can't have negatives values inside there. So there has to be a restriction on what you can plug in. In this case, the reason why we said x is less than or equal to 1, which was our h value, is because if we plug in a number smaller than 1, like 0, 0 minus 1 is negative 1, negative times negative makes it positive. So only those numbers would work. Anything bigger than 1 would not work, like 2 or 3 or 4. You might think, oh, well, those are positive. Yeah, but when you multiply times a negative, it makes them negative. Okay, so that's why these have restrictions. These do not. Because it's cube root, you can plug in a positive or a negative and it's fine. Okay, knowing that, and knowing what the graph is going to look like, from these points right here, I know that the graph is going to look something like this. Let me erase this end over here. Like that. Right? It's a cube root function, so I know that it does that little snake kind of shape, and I also know that it's flat on its ends like that, almost flat. So knowing that, I know that the domain, and again, you guys can get the exact shape by actually plotting the points. I'm not plotting the points because it would take too long for the video. Okay, I would get the not domain. Sorry, we're looking for the end behavior now. Looking at that, I can see the end behavior. On the left, it's going down. On the right, it's going up. So my end behavior is, let's talk about the left first. As x goes to the left, f of x goes down. As x approaches negative infinity, that means left. F of x approaches negative infinity, that means down. The right side, as x goes to the right, f of x goes up. And there you go. That is the end behavior. I just noticed something that I should have been paying attention to. It says that we're supposed to use a certain notation for the domain and the range. So this one says use set notation. That's correct. We use the correct notation. But I need to go back to the last one that we did to make sure we use the correct notation. It says use inequality notation. Okay. Inequality notation is basically set notation without all this stuff. You don't put it inside of a set. You just say x is less than or equal to 1, y is greater than or equal to 2. There you go. That's inequality notation. Okay, they're basically the same as set notation. You're not putting it inside of the braces. That's all. That's all, the only difference. All right, and that's it for number 14. Okay, let's continue with number 15. 1/2 x minus 1 quantity squared minus 3. So once again, they want us to find the inverse to restrict the domain, I believe. Oh no, we're transforming. Okay, I just completely lost where we're supposed to be doing on this one. We are transforming the function using the parent function table. Okay, so this one is a square. So we're going to start with x, y, my parent function table. My values for a square quadratic function is -2, -1, 0, 1, and 2. And my y values are 4, 1, 0, 1, and 4. I can transform that like this. So we're going to transform it using my parameters here. So according to this, what I have is b equals, b is in here, 1/2, but again, it's the reciprocal, so b is 2. H is 1. A would be outside, there's nothing there, so it's 1. And k is -3. There you go. Using those, I can go ahead and do the transformation now. Okay, I'm going to take -2, multiply times 2, and then add 1. So -2 times 2 plus 1. Remember, these two are for the x values, b and h, a and k are for the y values. So -2 times 2 is -4, plus 1 is -3. Do the same thing with the negative 1. Negative 1 times 2 is negative 2, plus 1 is negative 1. 0 times 2 plus 1 is 1. 0 times 2 is 0, plus 1 is 1. 1 times 2 is 2, plus 1 is 3. And finally, 2 times 2 is 4, plus 1 is 5. For the y values, times 1 minus 3. 4 times 1 is 4, minus 3 is 1. 1 times 1 is 1, minus 3 is negative 1. 0 times 1 is 0, minus 3 is negative 3. 1 times 1 is 1, minus 3 is negative 2. And finally, oops, I just messed up there somewhere. Yes, you saw the mistake, hopefully. 4 times 1 is 4, minus 3 is 1. It's going too fast. 1 times 1 is 1, minus 3 is negative 2. This should be negative 2. Alright. 0 times 1 is 0, minus 3 is negative 3. 1 times 1 is 1, minus 3 is negative 2. Okay, last one. 4 times 1 is 4, minus 3 is 1. This is just 1. There you go. You plot those points and that's your graph. Okay. The next thing you got to do is identify the domain and the range. In this case, your domain. Interval notation. Oh, never mind. We're not going to do it in that notation. Interval notation means this, right? Or sometimes we use brackets, or sometimes a combination of brackets and parentheses. So for this one, since it's a quadratic function, for quadratic functions, there are no restrictions on what you can have for your x values. You can have negatives and positives. That's why our parent function table here has negatives and positives in it. There are no restrictions. You could use any of them that you want. So because of that, the domain is all real numbers. In interval notation, that looks like this. Negative infinity, that's supposed to be a comma, to positive infinity. That's the domain. For the range, though, it does matter. Since it's a parabola, right? This is a quadratic function, so it's a parabola. The range does depend on what the bottom point is. What is the lowest possible point in my graph? I know this is a parabola that is going upwards because it's positive here. So it has to go that way. Another possibility is that it could be going downwards, in which case you look at the vertex, the top point. But anyway, the important point is the vertex, and the important number from the vertex is the k value, right? The y value of the vertex, which if you guys see, this is the original vertex. The new vertex is negative 3, which is this number right here. That determines your range. So the range is going to start at the vertex, including the vertex. So we're going to use bracket. The vertex is, the k value is negative 3. And then it includes all the numbers after that. Positive infinity. From negative 3 to positive infinity is the range. Last thing is the end behavior. I can see the basic shape of the parabola by plotting the points. So on the left it's going up, on the right it's going up. So what am I going to say for end behavior is on the left, as x approaches negative infinity, f of x approaches positive infinity. On the left it's going up. On the right it's also going up. And there you go. You got your table, which you're going to graph. You got your domain and range, and you got your end behavior. Okay, I'm going to continue with number 21. 18 through 22, I believe, are basically the same idea. You're going to find the inverse of a real-world situation. So I chose 21 because it seems to have decimals and fractions in it, so that's what throws some of you guys off. So I'll use that one. But the other ones are the same idea. It's the same basic idea. Okay, so 21, the function d of s equals 1 over 14.9 equals 1 over 14.9 s squared models the average depth d in feet of the water over which a tsunami travels, where s is the speed in miles per hour. So s is the speed in miles per hour. And d is the depth, right, in feet. So d stands for depth, s is speed. Speed stands for the speed over which a tsunami travels. okay, the speed in miles per hour, and d is the depth over which it travels. Okay, so how fast it's going, how deep it is traveling. Write the inverse function s of d to find the speed required for a depth of d feet. So basically, find the inverse of this. I'm going to write it not in function form. I'm going to write it as just d. So d equals 1 over 14.9 s squared. And I want to solve for s. The first thing I'm going to do is get rid of the 14.9 by multiplying both sides by 14.9. Right? If y'all multiply this by 14.9, that will cancel that. So it's just s squared equals 14.9 d. And finally, I'm going to take the square root of both sides, like that, like that. So what I get is s equals radical 14.9 d. And now we just need to find the inverse function to find the speed required for a depth of d feet. So that's it. That's the inverse function. We're going to write it in function form. S of d equals radical 14.9 d. It is perfectly okay to leave it like that. Another option is to write it, to find the square root of 14.9. So find the square root of 14.9 and write it outside. The square root of 14.9 is 3.86, so you could write it as 3.86 times radical d, and that would be the exact same thing, right? Both of those are the same thing. In the first one, I decided to leave the 14.9 inside the radical. In the second one, I found the square root of it and put it outside. So 3.86 radical d. What does this allow you to do? Now, if they give you the depth, you could find the speed, right? In this one, if they give you the speed, you could find the depth, right? It's written so that you can easily plug in s and find d. In this one, you can easily plug in d and find s. Same idea for this problem is what you're going to do for number 20, where they're asking you find c, so solve for c. Number 19, where they're telling you find the inverse right here, v of e, so solve for v. And then in this one, they are asking you to, once you solve it, plug in this for E. Kinetic energy is 4640. Same thing for 22. Find the inverse, solve for R, basically. So they're all basically the same idea. You want to isolate the other variable. All right, let's move on to the next set of questions. It says, write the function graph below for 23, 24, and I think 25 and 25 also. It's the same idea. Write the function, the function for the given graph. So I'm going to skip 23 and do 24 instead. They're the same idea. The reason why I'm doing 24 is because this one is pointing to the left, and that's something that some people always confuse. So we're going to go with this one. So let's do 24. There's two of them, and they're separate from each other. They're not the same thing. So we got to make sure we do one at a time and we keep them straight. So 24. For these problems, what you're going to do is you're going to find the four parameters. We've been doing this a lot already. B, H, A, K. And then also an x and a g of x. Right? These are the ones where you need those 6 things in order to find the function, the equation of this graph, basically. So here's what a graph I have. Also, you need to be able to identify what type of graph, what type of function it is. Okay? Big difference between these two. This is a square root function. It has an initial point and it goes in that direction. This is a cube root function, right? It does not have an initial point, but it does have a point of symmetry right there in the middle. This point right here is your most important point. That's your h and k. So 4 is h, k is 2. This point is h, k. That's what that point is. You pick another point, and that other point is your x and g of x. You can choose this one or this one, right? Either one of those two is your x, g of x. Doesn't matter which one you choose. I think I'm going to choose this one because it has a 0 in it, and everything that has a 0 is always, not always, but most of the time easier. So that's going to be 3, 0. That's my x, g of x. 3, 0. Next, what you need to do is figure out, do I need to solve for A or do I need to solve for B? they didn't tell you what. Most of the time I've been telling you, use this form, okay? So since they're not telling you, you choose which one you want to choose, okay, you want to use. The best way to choose is to look at the points that they gave you. Does it look like a horizontal stretch, which means that it's stretched horizontally this way, or a vertical stretch? And you can tell by looking at how the points are arranged. The points in the parent function are arranged like this, right here, negative 1, negative 1, 0, 0, 1, 1. They are right here. This is the parent function. I know that that's what it looks like for this type of function. They're really close to each other. So what happened to these points? Did they move away from each other horizontally, or did they move away from each other vertically? And you can see that they moved away from each other vertically, right? This point went up higher, this point went down lower, so they could be a little farther away. This is a vertical stretch, so we're going to use A. We're not going to choose B. We're not going to worry about it. We're going to solve for A. Using that, and knowing that this is a cube root function, I'm going to write my general form, which looks like this. G of x equals A times the cube root of x minus h plus k. That's what I'm solving for. Now I'm going to plug in my values. G of x is 0, A is A, times the cube root of x minus h, 3 minus 4, plus k, which is 2. 3 minus 4 is negative 1, so what you have is A times the cube root of negative 1 plus 2. The cube root of negative 1 is just negative 1, so negative 1a, or negative a, plus 2. And then finally solve by subtracting the 2. That gives you negative 2. Negative 2 equals a, negative a. Divide by negative 1 and you're done. A is 2. So that goes here. And now what you're going to do is you're going to plug all of these values, all of them, except for x and g of x, which you don't need anymore, into your general form, which is this. Plug in your h, your a, and your k into that, and you're done. So it's going to look like this. G of x equals 2 times the cube root of x minus 4 plus 2. Done. That is the function for 24, the first one on 24. Now let's look at the other one on 24 also. The steps are the same. You're going to find B, H, A, and K. So we're going to start with that. B, H, A, and K, and also X and G of X. In this one, your most important point is right here, the initial point. That's your H and K. See the difference? In this one, your H and K is that point right there, which we call the point of symmetry. In this one, your H and K is this point right here. So that would be negative 3 for H and negative 5 for K. Right? That point right there is HK. Negative 3, negative 5. And that's HK. You need another point, which they only gave me one other one, so I'm going to use that one. Negative 5, negative 3. That is your X and G of X. Negative 5, negative 3. And now we need to choose A or B. In this case, you have to use B. The reason is because the parent function for these types of functions, square root functions, should look like that, right? They always start at 0 and go that way. But this one's pointing to the left. As soon as it points to the left, we know that there is a reflection, a horizontal reflection, right? It jumped over the y-axis. So when it did this, that means that B has to be involved. Horizontal change is B. So we're going to look for B. We're not going to look for A. All right, so we're going to plug all of that into my general form, which looks like this. G of x equals, no A, right? Don't worry about A. 1 over B times x minus h and then plus k. This is a square root function, so there's no need to write the number here. In the last one, we had to put the 3 because it's a cube root. This is a square root, so no need to write it. Let's plug in everything. G of x is negative 3 times the square root of 1 over b times x minus h, negative 5 minus negative 3, so plus 3. And then plus k, which is minus 5. We're going to simplify this as much as we can. Negative 3 equals the square root of 1 over b. Negative 5 plus 3 is negative 2. Minus 5. Like that. And now we're going to solve it by adding 5 to both sides. I'm going to keep going over here. The negative 3 plus 5 is 2 equals the square root of 1 over b times negative 2. That's just negative 2 over b. Right? Remember how we were doing that? This is just negative 2 over 1, so it's just negative 2 over b. Now we got to get rid of the square root, and we're going to square it for that. Square, because that cancels that. We're going to square this one as well. So we have on the left side 4, on the right side negative 2 over b. And we're going to solve this. We're not going to make our life difficult. We're just going to make a proportion here. Put a 4 over 1 and cross multiply to solve. 4 times b is 4b. Negative 2 times 1 is negative 2. b is negative 2 over 4 because we're dividing by 4. And so finally b is negative 1/2. That's b, negative 1/2. And we're done. Plug all those values, the 3, except the x and the g of x, into the general form, into this one right here. So this is our final answer. G of x equals the square root of 1 over b. If b is negative 1/2, the reciprocal is negative 2. X minus h, x plus 3, plus k minus 5. Outside the parentheses, there it is. That's it for that one.